Hello everyone, I'm Brother Gia from Saja Acoustics and Lighting Engineering. Let me share with you some knowledge about ISO electroacoustic simulation software. What's the difference between scattering coefficient and diffusion coefficient? In recent years, with indoor sound computer simulation technology playing an increasingly important role in indoor acoustic design, the impact of sound scattering on indoor sound field has received growing attention, particularly regarding the precise description and measurement of surface scattering coefficient, as well as the increasing demand for scattering coefficient data. The degree of surface sound scattering plays a crucial role in various aspects of room acoustics, like factories and reverberation chamber research is extremely important. Insufficient scattering can lead to significant deviations from exponential sound pressure. On the other hand, using highly scattering surfaces can achieve approximately diffuse sound field. The degree of room scattering is a key factor related to indoor acoustic quality. Both scattering coefficient and absorption are very useful in room acoustic simulation and predictive modeling. Establishing surface scattering is essential for obtaining reliable room acoustic predictions. Specular reflection follows Snell's law of reflection, where the angle of reflection equals the angle of incidence. Specular reflection can be approximated using rigid planes, much like the wavelength of incident sound. Comparison between scattering and diffusion scattering coefficient, diffusion coefficient. DC versus AC, SUN. Definitions of scattering and diffusion. Scattering coefficient refers to the ratio of scattered sound energy to total. Diffusion coefficient evaluates the uniformity of reflected sound energy without clear physical meaning. Where to measure scattering and diffusion. Measuring scattering coefficient testing in anechoic chambers for single incidence angle results, or in reverberation chamber for random incidence results. Diffusion coefficient is measured in free field conditions or conducted in a semi-anechoic chamber. 5. Scattering coefficient application scenarios. Scattering coefficient refers to ISO point software. More practical, suitable for auditorium acoustic. Difficult to predict. Diffusion coefficient suitable for diffuser designers, easy to predict. 6. Scattering coefficient and measurement basis. Measurement of scattering coefficient. According to International Organization for Standardization ISO 17497 standard, established in reverberation, a set of acoustic scattering coefficient test system, then using this system to test the scattering coefficient of MLS diffusers and sound absorption coefficient with test results provided. Measurement of diffusion coefficient based on AES Audio Engineering Society. 7. Scattering coefficient and diffusion. Whether considering directivity of reflected sound. Scattering coefficient doesn't consider activity of reflected sound. Diffusion coefficient consider directivity of reflected sound. 8. Scattering coefficient and diffusion coefficient. What's the difference between two absorption coefficients? Scattering coefficient refers to random incidence absorption coefficient. Diffusion coefficient refers to normal incidence. Scattering coefficient is suited auditorium acoustics design. Difficult to predict. Diffusion coefficient is diffuser designers. Easy to predict. Scattering coefficient is measured in reverberation. Diffusion coefficient is measured in impedance. Scattering coefficient testing. Large sample area needed, approximately, yielding closer to actual production conditions. National standard uses reverb to determine absorption coefficient as the evaluation basis for sound absorption performance. Diffusion coefficient measurement, very small material area, simple test setup. Accurate test results, suitable for acoustic theory research. Optimization of sound absorption material. 9. Comparison between scattering quantity and absorption. Different from sound absorption materials, or absorption quantity is proportional to area. Factors affecting the scattering performance of diffusion. More complex. Given diffusers with identical maximum, the diffusion coefficients of single versus multiple diffusers show significant differences. As the number of diffuser array periods increases, the diffusion coefficient tends to decrease while the scattering coefficient remains largely stable. With increasing depth, both diffusion and scattering coefficient generally increase. More grooves per period leads to higher diffusion and scattering. Thank you for watching. Looking forward to our next sharing session.